Hi everyone, welcome back to Java Programming. In this video, I'm going to give you an introduction to inheritance. In object-oriented programming, inheritance is a key concept. By inheritance, I'm referring to superclass and subclass relationships, which we started off the semester talking about with the shapes, the square, circle, triangle, and polygon. And we used that as a way to kind of understand what objects were. Now we're going to use that same example to understand the superclass and subclass relationships. And really what we get out of that is the ability to reuse the code that we write. So we only write code in one place, and then we can reuse it in some of our other classes. So that's where we're headed with that. Avoiding duplicate code, that's really key. In fact, a lot of the tools will check for us to make sure that we don't have duplicate lines of code. That's a bad practice, so we're working on writing very clean code by writing code only in one place and reusing it then, or referring to it. We'll also talk about design a little bit more, designing using an inheritance tree to help us understand the relationships between our classes, and an is-a-has-a test to determine if a particular thing should really be a class, or is it maybe just an attribute of a class, an instance variable. We'll learn about what exactly we inherit from a superclass and what that really gets us. And I've kind of alluded to that as that reusability, minimizing how much code we're having to write. That brings us to polymorphism. And that's a key term that you'll hear within object-oriented programming very often, and we'll learn more about exactly what that means and what that buys us. A couple more terms, overriding and overloading of methods. So we talked a brief bit about overriding methods, meaning changing the behavior of something in the subclass. So our polygon, if you remember, had different behavior. It spun differently and it played a different sound than our other shapes. So we were overriding a particular method there. And we'll talk about overloading as well. So let's go back to that original example that we kind of started off the semester with, where we had our shape, and the shape was our superclass. The shape had a couple methods in it, rotate and play sound. Excuse me. And if you remember, square, circle, and triangle all kind of had the same behavior, right? They all rotated the same way and they all played the same sound. So those subclasses, we didn't have to add any additional code into those because they just inherit the code from the shape. So the shape is our superclass. It's more abstract than the subclasses being more specific. And then we had that new polygon type that was introduced, and the solution was to add a new class. And the cool thing about that, if you remember, is that we could add that class and it didn't affect any of the existing code that we already had. The things that were different about polygon was that there were a couple new instance variables, an x and y coordinate, and that was the rotation point for the polygon. So it rotated differently than our other shapes, which meant we have then an overridden rotate method. So we're overriding the behavior of the shape in the polygon. So there would actually be different code within the polygon than what we saw in the shape. And same thing with the play sounds. We're overriding the play sound method in polygon. So again here, what are we getting out of this? Well, that rotate method, I only have to write it once, and square, circle, and triangle all can still use that method, and we'll see how that works in a little bit. Same thing with play sound. I only have to write that code in one place, yet square, circle, and triangle all have access to that, and they can all still play sounds and rotate. But this way, if I have a change in how the play sound method is supposed to work, I only have to make that change in one place, not in each of these classes. So we'll learn how to do that in code in just a little bit. Before I do that, I want to just take a look at a couple more examples to help emphasize the superclass-subclass relationship and the different parts of the classes. So here we have a superhero class, and instance variables on the superhero, a suit, and tights. And then the methods or behavior, things that we can do to the superhero or that the superhero can do, use special powers and put on the suit. And this notation here that we've got is universal modeling language. You'll get a little bit of this in some of your analysis and design classes as well. But what this arrow and the line show is that Fried Eggman is a subclass of superhero. Okay, it extends from that. And same thing with Panther Man, extends from or is a subclass of the superhero. Fried Egg Man doesn't have any additional instance variables and no additional methods. So the things that Fried Egg Man can do are all defined in the superhero. As far as Panther Man has not any different instance variables or methods, but instead the methods are overridden here. So Panther Man's implementation of the use special power is going to be different than just the generic or the abstract or more abstract superhero. And same thing with putting on a suit. You think about Panther Man maybe has a big panther tail that needs to be threaded through a hole in the back of the suit. So putting on this suit for Panther Man is going to look a little bit different than the superhero. All right, how about one more? We'll take a look at actual code after we look at the diagram here, so things will start coming together a little bit more. So here our superclass is a doctor, kind of a generic or more abstract type. Instance variable, figured this would be a Boolean, works at the hospital, and there's one method, treating a patient. Now we've got two subclasses that are more specific, surgeon and a family doctor. Those are pretty different classes if you think about it. And here our surgeon is going to override treating the patient. The surgeon treats a patient probably differently than just our generic type doctor. And the surgeon has some special capabilities, so it has an additional method, make incision. On the other side, we have a family doctor, a new instance variable there that really only applies to a family doctor, being able to make house calls, not something that would make sense for our surgeon. And then the family doctor also has a new method, give advice. So in terms of treating the patient, the family doctor code for that is going to be in doctor. And if I tried to call treat patient on family doctor, it's the code in doctor that would run. So in surgeon, if I call treat patient, it's the code in surgeon that would actually run. So that's the difference here. Let's take a look at what that looks like in terms of the code. So remember doctor, we've got an instance variable and a method. And here's that class, public class doctor, a Boolean works at the hospital, and a method treat patient, and you can imagine some code in here, whatever that might be. That class should look familiar. It's kind of like what we've been working with all semester. What's new is the subclass and how we write that. So the subclass, if we take a look at the family doctor, subclass of doctor. So that relationship is in the class declaration. So public class family doctor, everything's the same there. And then we use the keyword extends to indicate that subclass relationship. Family doctor is a subclass of doctor, so it extends doctor, and that's what this notation indicates here as well. Then inside of that class, I don't have to specify works at hospital. I get that automatically because I'm extending doctor. So you can kind of imagine that there's a works at hospital instance variable here. Same thing with treat patient. I also have access to that as a family doctor extending the doctor. What's new is the give advice, all right? So the give advice method is on family doctor, so that I need to actually add in here and potentially add some code. Over to the surgeon. The surgeon also extends doctor. It's a subclass of doctor. Here we are overriding the treat patient method. So something that you need to keep in mind when you're overriding a method is that the signature, the method's signature, needs to be exactly the same. So void treat patient, no parameters. We've got the exact same thing here. If I change this and added in a parameter on treat patient, I'm no longer overriding the doctor's treat patient, but I'm instead overloading that. And we'll talk more about the differences between those two as we get further into this unit. And then the surgeon also had a new method, make incision, so same thing as give advice with the family doctor. We're going to have an implementation of that only in the surgeon class. So that's a lot of stuff. We've learned about what the diagrams look like to explain inheritance in pictures using the arrow to show that surgeon is a subclass of doctor, for example, and the fact that we use the extends keyword to do that. Subclasses can have their own variables and methods. We just saw a case of that with surgeon and also with the family doctor. The superclass just holds the code that's common for all of the subclasses, okay? And then we talked about overriding. So overriding that treat patient method, for example. So that sets you guys up to be able to start working with superclasses and subclasses in Lab 1 and also overriding in Lab 2. I'm going to come back with a demo using the vehicle example that we've been working with. So we're going to turn our vehicle into a superclass, and then we're going to create a couple subclasses there. And then I'm also going to come back with another demo overriding a method. So if you want to start these labs and give them a try, go ahead and do that. If you prefer to see a demo and then hit those labs, that works too. So choose the order of these things that works best for you. If you want to start them and then watch some video and come back and finish up, that's great. All right, we'll see you in the next video.